Hello. In the last video, we introduced quadratic equations, quadratic functions, parabolas, and we looked at three different forms that they were in, and we ended with kind of a recap, and we saw that the factored form, when a quadratic is in the form a times x minus z1, x minus z2. Really, we can see this as our two factors for this quadratic. So in order to solve quadratic equations, one of the first steps that we will try to do is we'll just try to factor it. Because if we can do that, we can easily solve it. So for example, x squared equals negative 10x. We'll move that 10x over. Okay, so now that it's set equal to 0, I can factor this. I could factor out x. And we have this really nice property in the real numbers, that if two numbers are multiplying to be 0, one of them is at least 0. So this is what we call this zero factor principle. Once I factor it, once I get it into this factored form, I can set each piece equal to 0 and solve it separately. So this side's done. This side's obviously very easy to solve. And so I have my two zeros of the quadratic equation. And it's just as easy for the equations that we had before. If I have x squared plus 3x minus 28, I'll go ahead and use my table. I need two numbers that multiply to be negative 28 and add to be 3. I'll go in order. 1 times 28, and if they're multiplying to be negative, one's negative, one's positive. And adding to be positive means the smaller one's the one that's negative. Okay, so I have that. 2 goes into 28, 12 and 14. 3, we can try. 3 doesn't go into 28. 4 does. That's 4 and 7. We can try 5, it doesn't. We can try 6, it doesn't. And then 7 means we're right back where we started. So I could sit and add them all together, but I think it's pretty clear that negative 4 plus 7 is 3. So again, we'll use that to break up our middle term. Because now we can factor by grouping. I can factor 7 out of these two terms. Now I can factor out x minus 4. And I'm left with that x plus 7. This is where we kind of stopped with in module 3, or module 2 factoring. So at this point, we've factored the left side of the equation, and it's set equal to 0. So now I can use this zero factor principle to solve the two separately. And so again, I have my two solutions. Now, you'll start to notice that we will always get two solutions, two zeros, for our quadratics. And really, that's because if I have some parabola, we can see that it's either going to cross like this, where it's crossing in two places, like this, where it's crossing at exactly one place, which means if I solve it separately, I'll actually just have the same copy of the number. Now, this is the easiest case, is just the function x squared. And then my only other option is for the parabola to completely miss the x-axis. So I'll either have 0 solutions, 1 solution, because it's a copy, or 2 distinct solutions. All right. A couple more examples, just real quick. Again, we had these before where we're trying to get the 2 factors, and just like before, this should say equal to 0. Just like before, if we really do want to solve these equations, the very first thing we should do is factor out any numbers. In this case, I can actually factor out a 3. So when we were just factoring, we kind of ignored that piece, factored for the rest of the way, and then kind of attached it at the end. But in this case, I've taken out my 3, I factored out my 3, and if I divide both sides by 3, it goes away. So the first thing that we should do when we're trying to solve these quadratics is try to factor out a single number from the trinomial. Okay, so now that the numbers are a little bit smaller, we want to find 2 numbers that multiply to be 28 and add to be 11. If they're multiplying to be positive and adding to be negative, they're both negative. And so I'll go in order. I try 3, it doesn't work. I try 4, and I see that's the one that I needed. So I use that. Let me draw this down here so I have room. So I use that -4 and -7 to break up the middle term. I pull out a w from these first 2 terms. Now this has 7w minus 4, and these 2 are the opposite, so I must need to just pull out -1 to get 7w minus 4. Well, that means I have 7w minus 4, w minus 1 equals 0. And now I can set them equal to 0 separately and solve. So this would be adding 4 and dividing by 7. So I'd have my 2 solutions here. So I'm going to go ahead and skip this example. It looks exactly the same. And I want to focus on this last one that's over here. 9x squared minus 3x minus 1 equals 0. So I can't pull out any number. So I'll try to find 2 numbers that multiply to be -9 and add to be -3. So if they're multiplying to be negative, one of them's negative. And they're adding to be a negative number, so the larger one's negative. 2 doesn't go into 9, 3 does. And then we realize we're out. One of the nice things about using this table is now when we get to these quadratics that we can't factor, we'll know we're done. We don't have to try to rack our brain, and that's especially useful if there are more terms, like in this case. And what that means is we can't factor, we can't solve this by factoring. So we'll need some other method. And that'll be what the next video is on, it'll be the quadratic formula, which I'm sure a lot of you have heard of before.